customer makes exactly one selection from each of the 5 categories listed above: 10 ice cream flavors, 8 kinds of candy, 5 liquid toppings, 3 kinds of nuts, and with or without whipped cream. What is the greatest number of different ice cream sundaes that a customer can create? First of all, is the order of the ingredients important? Since the order of the ingredients is irrelevant, this problem involves combinations. Of 10 ice cream flavors, we're choosing one of them. Of 8 kinds of candies, we're choosing one of them. Of 5 liquid toppings, we're choosing one of them. Of 3 kinds of nuts, we're choosing one of them. And with or without whipped cream, we're choosing one of them. Finally, we're going to apply the product rule, since each kind of ingredient is a single task. Do not forget that. And combinations of n objects, if you're choosing just one of them, equals n. Therefore, 10 times 8 times 5 times 3 times 2. 5 times 2, 10. 8 times 3, 24. So we get 24 times 10 times 10. 2,400. Choice C is correct. There are 6 men working in a factory. In how many ways can a 4-man committee be formed? First of all, is the order of the members of the committee important? Since in a committee the order of the members is irrelevant, this problem involves combinations. Of 6 men, we're choosing 4 of them. And this one is equal to 6 factorial over 4 factorial times 6 minus 4 factorial. First of all, we need to solve this one, which is 2, and we get 6 factorial over 4 factorial times 2 factorial. 6 factorial is the same as 6 times 5 times 4 factorial over 4 factorial times 2 factorial is 2 times 1, which is 2 at the end. Now, we can cancel 4 factorial with 4 factorial, and we can cancel this one, and we get 3 on top. So finally, we get 3 times 5, and this is 15. We can form 15 different committees of 4 men out of these 6 men working in a factory. Choice B is correct. How many different 6-letter words can be formed using the letters of the word repeat? Now, first of all, is the order of the letters important? Since the order in which the letters are arranged matters, this problem involves permutation. Now, repeat is a word that has 2 E's. Therefore, which formula shall we use? We need to use the formula of permutations with repetitions because repeat has two indistinguishable elements. Therefore, permutations of 6 objects where we have 2 indistinguishable objects, and this is equal to 6 factorial over 2 factorial. Now 6 factorial equals 6 times 5 times 4 times 3 times 2 times 1 over 2 factorial is 2 times 1, just 2. So finally we can cancel this one and this one. And finally we get 20 here, and over here we get 18. Finally 18 times 20 equals 360. Choice C is correct. How many 3-letter words can be made using the letters of the word smart without repeating letters? First of all, in order to make new words, will the order of the letters make a difference? Since the order in which the letters are arranged matters, this problem involves permutations. Only 3 different letters of smart must be used. Therefore, we'll use a formula for permutations when the size changes. Out of 5 different letters, we're gonna choose just 3 of them, and this is equal to 5 factorial over 5 minus 3 factorial according to the formula. This is 5 factorial over 2 factorial, and 5 times 4 times 3 times 2 times 1 over 2. We can cancel this one with this one, and finally we get that permutations of 5 objects, choosing just 3 of them, equals 5 times 4 times 3. That is finally 60. Choice D is correct. Felipe is 6th, and other 3 kings are scheduled to sit in a circular table of 4 chairs. How many different seating arrangements are possible? Now, first of all, is the order of the kings important? Since the order in which the 4 kings are going to sit matters, this problem involves permutation. They're sitting at a circular table. Therefore, we're gonna use the circular permutation formula. Circular permutation of n objects equals n minus 1 factorial. In this problem, n equals 4. Therefore, circular permutation of 4 elements equals 4 minus 1 factorial. Finally, we get 3 factorial. 3 factorial equals 3 times 2 times 1, which finally is 6. Choice B is correct. How many different words can be formed using the 7 letters of the word Kalvirs if the 2 vowels cannot be next to each other? So, first of all, is the order of the letters important? Since the order in which the letters are arranged matters, this problem involves permutations. Now, in order to find what they want, we need to calculate the complement. Calculating the complement involves to calculate the opposite case. They want the 2 vowels away from each other. So we're going to calculate the case in which the vowels are always together. So we need to assume that A and I are one letter. So the new total number of letters would be 6. And this is permutation of 6 different objects, which is 6 factorial. Now we're going to multiply 6 factorial by 2 because there are 2 ways to get the vowels together. A and I and I and A. And finally, we need to subtract this quantity by the total number of ways all the letters can be rearranged with no restriction, which is permutation of 7 different objects. This is 7 factorial minus 2 times 6 factorial, and this one can be written as 7 times 6 factorial. And we can do this 6 factorial times 7 minus 2. Finally, we get 6 factorial times 5. 6 factorial equals 720 times 5. And finally, this one equals 3,600. Choice E is correct. President Obama and 4 other dignitaries are scheduled to sit in a row of 5 chairs. If the president must sit in the center chair, how many different seating arrangements are possible for the 5 dignitaries? Now, first of all, is the order of the dignitaries important? Since the order in which the dignitaries are arranged matters, this problem involves permutation. Now, shall we count Obama in the total number of people to be rearranged? We'll consider only 4 people to be ordered since Obama must be in the center chair always. Therefore, permutations of 4 different objects equals 4 factorial. Finally, 24 is our answer. Letter D is correct. A certain academy has 3 math teachers and 5 verbal teachers. How many teams of 3 teachers can be formed if each team must include at least 1 math teacher? Now, first of all, is the order of the teachers per team important? Now, since the order of the teachers is irrelevant, this problem involves combinations. The team must include at least 1 math teacher. It means that there are 3 different kinds of groups that fit to the requirement. A group of 3 math teachers, a group of 2 math teachers, and 1 verbal teacher, and a group of 1 math teacher, and therefore 2 verbal teachers. We need to find how many groups are possible for each combination. Now, there's only 1 possible group of 3 math teachers since there are only 3 math teachers. Just 1 group. Now, in the second case, we're gonna form a group of 2 math teachers and 1 verbal teacher. This is out of 3 math teachers, we're choosing just 2 of them. And out of 5 verbal teachers, we're choosing just 1 of them. And according to the product rule, we must multiply both quantities in order to find how many groups can be formed. Same way for the third case. Out of 3 math teachers, we're choosing just one of them, and out of 5 verbal teachers, we're choosing 2 of them. And finally, sum up all possible groups. So first we need to calculate this one and this one and this one and this one. So do not forget that combinations of n objects, we're choosing one of them, equals n. So this is 5 and this is 3. Now we're going to calculate this one. Right here, 3 factorial over 2 factorial times 3 minus 2 factorial, which is 1 factorial, and finally we get 3 times 2 factorial over 2 factorial. We can cancel this once, and finally we get 3. So this is 3 times 5, and this one, we can do this. So 5 factorial over 2 factorial times 5 minus 2 factorial. So finally we get 5 factorial equals 5 times 4 times 3 factorial over 2 factorial is 2 and 3 factorial. So we can erase this one. Finally we can cancel 3 factorial and 3 factorial. So finally we get 2, and 5 times 2 equals 10. So this one is 10 and this one is 1. So finally 1 plus 15 plus 30 46. Choice C is correct. Now another way to solve this problem is, I'll erase this calculus, and so another way to solve this problem is by subtracting the total number of groups of 3 teachers, that is, out of 8 teachers, we're choosing 3 of them, by the number of groups that can be formed including only verbal teachers. So out of 5 verbal teachers, we're choosing 3 of them. So finally we get a factorial over 3 factorial times 5 factorial, because this is 8 minus 3 factorial minus 5 factorial over 3 factorial times 5 minus 3 factorial. And if you calculate this one and this one, you will finally get that the result is 46 as well. So this is another way to solve the problem. Carolina and Sergio are in a group of 6 people. How many different groups of 4 people can be formed that includes Carolina and not Sergio? So first of all, is the order of the people in the group important? Since the order of the people in a group is irrelevant, this problem involves combinations. Now, Carolina must be in the chosen group of 4 people. So we get here Carolina. And the remaining 3 people. Since there are 6 people and Carolina is already chosen, there is 5 people missing that can be chosen randomly to fill these 3 spaces. So we need to remember that Sergio cannot be in the group, so there is only 4 remaining people to fill these spaces. Finally, we get out of 4 people, we're choosing just 3 of them, and this is 4 factorial over 3 factorial times 4 minus 3 factorial. And finally, we get 4 factorial over 3 factorial times 1 factorial. 4 factorial equals 4 times 3 factorial over 1 factorial is just 1, it doesn't matter, over 3 factorial, and we can cancel this one, and this one. So we get that choice B is our answer.